Hey there, science fans! Have you heard about the electrician who got a raise? His boss told him watts up. Get it? Because watts is a unit of power? Okay, I know, I'm working on my material, but let's get serious for a moment. Today we're diving into the world of capacitors. These little components might seem insignificant, but they are absolutely essential in modern electronics. Capacitors are like the superheroes of the electronics world, storing electrical energy and releasing it when needed. Imagine them as tiny batteries that can charge and discharge rapidly. They're small, but mighty, playing a crucial role in everything from smartphones to electric cars. Without capacitors, many of the devices we rely on daily simply wouldn't function. In this electrifying journey, we'll unravel the mysteries of capacitors, from their humble beginnings to their modern-day marvels. We'll explore how they've evolved over time and the incredible advancements that have been made. So buckle up and get ready for a shockingly informative adventure. Whether you're a tech enthusiast or just curious about how things work, this journey will spark your interest, and maybe even inspire you to learn more about the fascinating world of electronics. Our story begins in the 18th century with a Dutch scientist named Peter van Musschenbroek. He was a man of great curiosity and intellect, always pushing the boundaries of what was known at the time. Picture this. It's a dark and stormy night, and Van Musschenbroek is experimenting with electricity, trying to store this mysterious force in a glass jar. The air is thick with anticipation and the smell of ozone. He fills a jar with water, sticks a metal rod in it, and connects it to a static electricity generator. The room is dimly lit, with only the occasional flash of lightning illuminating his focused expression. Sparks fly, the jar crackles with energy, and voila! The Leyden jar, the world's first capacitor, is born. This simple yet groundbreaking invention would pave the way for future advancements in electrical storage. Now, I wouldn't recommend trying this at home. Van Musschenbroek got quite a shock when he touched the metal rod, literally. The jolt was so intense that he later described it as a blow to his whole body. But hey, at least he discovered something amazing, right? The Leyden jar was a monumental step forward in the study of electricity, and it all started with one man's curiosity and a stormy night. So what exactly is a capacitor? Imagine a sandwich. You've got two slices of bread which are like the capacitor's conductive plates. These plates are usually made of metal and are essential for storing electrical energy. In between, you've got a filling like peanut butter or jelly, which acts as the insulator or dielectric. This dielectric material prevents the plates from touching and allows the capacitor to store energy efficiently. In a capacitor, these plates store electrical energy when connected to a voltage source. The energy is stored in the electric field created between the plates. It's like charging a battery, but much faster. Capacitors can charge and discharge their energy in a fraction of a second, making them incredibly useful in electronic circuits. And just like you can have different types of sandwiches, capacitors come in all shapes and sizes, each with its own special purpose. Some are tiny and used in small electronic devices, while others are large and used in power systems. Capacitors are found in almost every electronic device you can think of, from your smartphone to your TV. They help regulate power, filter signals, and even store energy for later use. Understanding how capacitors work is fundamental to understanding modern electronics. They are one of the building blocks of the technology that powers our world. Section 4. How do capacitors work? Okay, so how do these electrical sandwiches actually work? Well, when you connect a capacitor to a voltage source, one plate becomes positively charged, and the other becomes negatively charged. It's like a tiny electrical tug-of-war. The dielectric material in between prevents the charges from jumping across, so they build up on the plates, storing electrical energy. Then when you connect the capacitor to a circuit, it releases that stored energy like a bolt of lightning. Section 5. Real-world applications of capacitors. Capacitors are everywhere in our electronic gadgets. They help smooth out the flow of electricity in our computers, ensuring our screens don't flicker like an old horror movie. They power the flash in our cameras, capturing those Instagram-worthy moments. And in electric cars, capacitors store massive amounts of energy, giving them the juice to zoom down the highway. They're like the energy drinks of the electronics world, providing that extra boost when needed. Section 6. Capacitors. Tiny but mighty. So there you have it, the shocking truth about capacitors. They may be small, but they're essential components in our electronic world. From powering our smartphones to propelling electric vehicles, capacitors are silently working behind the scenes, making our lives brighter, faster, and more connected. And hey, the next time you take a selfie with your smartphone, remember the tiny capacitor that made it possible. Keep on exploring, science fans, and stay curious.